Good afternoon, everyone. My name is Mansoor Arora from Lepton Software, and we welcome you all for today's webinar on the topic in building inventory. We hope that everyone is safe and healthy, and thank you for joining us for this special session. The session will be for 30 minutes, and we will have a Q&A session at the end of the presentation. I would request you all to kindly type your questions and queries in the Q&A window, and we will take them after the presentation is finished. We will be also having a demo of the software solution during the session. Our speaker for the day are Mr. Shyam Devi Reddy and Mr. Harshit Singhal. Uh, Mr. Shyam is the Director of Product Network Access at Lepton Software, responsible for product management, solutioning, and pre-sales. He has a wide experience working with industry majors like Ericsson, Telecodia, Esri in their global operations. Mr. Harshit is working as pre-sales specialist, telecom, responsible for solutioning, requirement analysis, and technical engagement. He also has a wide variety of experience and working with some of the telecom majors like Reliance Jio in their FTTX planning and NSN as transmission planning engineer. Now, I would request Mr. Shyam to take the session ahead with his presentation on the topic of the day. Mr. Shyam.
Right. Thanks, Mansoor. Quick check. You're able to hear me loud and clear?
Yes, sir. We are able to hear you.
Very good. Thank you. Thank you. Welcome, everybody. Good afternoon. Good evening, wherever you are in the world. As Mansoor introduced, today's topic is focused on in-building inventory. Before we get on to the in-building inventory, just want to get the basis right. An inventory solution, specifically with telecom network management, primarily addresses the use cases or the needs to plan and inventorize both wireless and wireline networks. Not only the networks, but it also has got the civil and cable components, like civil elements like ducts, manholes, handholds, sites, and the cabling as well as splicing and the equipment that make up the whole network. So making a plan and inventorizing them, both the OSP assets as well as the ISP assets, typically all the OLT type of equipment, active equipment in the inside plant or in exchange building or a wire center. So bringing all those network assets together and inventorizing them in one place is one of the key area that inventory solution typically addresses. Of course, once you have the inventory, you want to visualize them typically on a map base to understand the geographic context of how the network is connecting right from the exchange to the customer end, and what are the relationships that make up the whole network and dependencies, things like that. So you want to have smart visualization on a geospatial base or map base or a schematic or a PDF document that you can take to the field. So different kind of visualizations is what inventory solution typically supports. So it's all well and good for an OSP on a map base, but in a case of ISP inside plant, you'd want to have flow plans and rack views and things like that. And moving on, once you have the inventory and the relationships and the connectivity, the port-to-port connectivity in place, you next use it for analyzing how the signal flow is happening and what's the impact of something, picking up a particular piece of fiber and trying to understand what is the impact of fiber not working properly. All those type of analysis and the costs to build the network is what a solution typically supports. Finally, you would use to report, like the one that said the cost, trying to create a bill of material and a bill of quantity reports, and do a trace and analyze and say, what impact downstream for a particular piece of element or upstream. What is the capacity utilization? All those type of analysis will result in conducting or producing a report. A network inventory solution typically addresses these particular areas. However, there's one area most of network inventory solutions are not addressing yet. That is in building networks. So you have a multi-story building, and within a multi-story building, you have uh, the splitters or the equipment placed at the bottom of the building, and then you have risers, and then the drop cables connecting the customer premises equipment, and how those are getting connected, and how many customers are there in a particular floor, in individual flat. All those type of information is what most of the inventory systems are not supporting in the market right now. And Lepton is introducing that particular solution to start with. So before I go into the in-building inventory, as I mentioned earlier, the typical functionality, the key functions that inventory solution supports is the OSP and ISP, outside plant, inside plant facilities. What are the attributes or what are the properties of each of these elements, how they're connected to each other, and visualizing them using different symbology on a map base. All of that is a key functionality inventory solution supports. And of course, understanding and documenting and understanding port-to-port connectivity, right from ODF and OLT on the central office building or exchange building, all the way back to the CPE, flowing through the cables, multiple ODFs, multiple splitters, and all that stuff. And able to trace that end-to-end port-to-port connectivity to analyze that information, analyze the capacity utilization and impact, and all of that uh, forms the key functionality of inventory system. And visualizing that on a map base like the one above, and creating a schematic, single line diagrams to understand how a particular customer is connected or which port is connected to what. And finally, accessing all this information across the organization, whether you're using a web browser, a standard web browser, or a mobile client, trying to do operations in the field. So bringing all the information together, storing them at central location, and providing access both on a web browser or mobile client form the key functionality. But as I mentioned earlier, in building inventory is something that most solutions have not been doing, and we've introduced the in-building inventory in our smart inventory solution of Lepton Network Access. The objectives of this is basically to have a single data model, both for the OSP, ISP, as well as in building. So irrespective of which area you're working, whether you're working inside an exchange building or whether you're working customer multiple dwelling unit or the OSP assets, whichever area you're working on, one single solution helps to plan, record, and inventorize all your network elements. So that's the objective of the inventory in-building inventory solution. And of course, seamless integrate all the network elements irrespective of their domain. Map customer premise equipment, plan for it, map it, connect it, and trace it. So all those typical functionality you expect of inventory system seamlessly working together is another objective. And not only that, you want to model all your network elements, like you want to place the equipment at different points. Maybe at the basement, you have a larger piece of equipment, and each floor you have another piece of equipment. And this one is giving rise to the risers and all the cables. So all those equipment that you want to place at different points. And in between, you want to do some splicing. So support the splicing as a part of in-building inventory. And cable risers, cable drops, everything that you expect of an in-building inventory, the solution should be supported. But not only that, you want to actually see the floors, how the floor plan is, and how the distribution of individual flat is. So looking at them and reaching all the way to the customer's equipment and maintaining the whole end-to-end connectivity. So the solution supports all the important use cases you want to have as part of in-building inventory. And it comes to the rich functionality within the framework of smart inventory to place an MDU, define the tenancy of the MDU, whether it's a single tenancy or multiple tenancy, and categorize them, whether it is residential, commercial, and also capture the home pass count, so that the solution can help you conduct the plan based on home passes. So a rich functionality for you to capture all the properties of a high-rise building, like a multi-dwelling unit, is part of the solution. Once you do that, you can also define how many floors the MDU has, and within each floor, you can define the number of units each floor has. And using these inputs, it automatically tries to create a view, a visualized representation of the floors and the number of flats or units in each floor, and allow you to place the splitters or any other type of equipment that you want to place, and make your plans accordingly. Not only that, it also captures dimensioning information as well. So once you provide the size of the units as well as floors, it will dimension them based on the dimension information that is provided. So once you have that, you can conduct your cable layouts, whether they are risers or drop cables. You can have multiple type of cables. You can have configure different size of the cables that you want to use, and use that as a part of your plan and design. Once you do that, you can then later on connect the network elements, at a port level, at an individual port level. So you can pick up, individual port within a cable, fiber strand with two cables, and then do the splicing, or pick up equipment like a ONT and then connect it all the way back to drop cable. So all that connectivity establishment to enable you to do port-to-port information capturing, allowing you to trace right from customer to all the way back to the exchange. All that goodness of detailed low-level connectivity can also be captured within the in-building inventory environment itself. So that's in summary of what the solution is all about and how the solution allows you to take advantage of the smart inventory platform and help you manage your in-building inventory needs. I will now hand over the session to my colleague Harshit for a live demonstration of the solution. Harshit, if you can take control, please.
Thank you, Shyam sir, for the wonderful presentation. Now I would request Harshit to take over and present the demo to our audience.
Thank you, Shyam sir, for the wonderful presentation, and a very good day, everybody that who have joined this webinar of Inbuilding Inventory. My screen is visible to all. Yeah.
Yes, Harshit, we are able to see.
Thank you, Mansoor. In continuation to that in-building inventory, so on my screen that you can see that there's existing network, a brownfield network that is already present on the map. That is, if I just want to get the information of this network and I want to see that they are all the civil elements, the cables, the equipments, all the things are already placed over this map. Now I want to add
Harshit, we lost you in between. Can you please
that
repeat?
will connect? Yes. My screen is visible.
Yes, your screen is visible, but your voice is breaking in between.
Okay. So what I will say is that for this inventory, what we can do is that to connect the in-building to a building from the existing network, we can plan the in-building design of that particular building so that we can make use of the existing network to connect the new buildings to the existing network. So here you can see there is an existing network that is already in place. Now, if I just zoom in into this particular location, you'll see that there is a near manhole, and with this manhole, there if I place a new building, then how I can be able to create the in-building design. So first of all, I will place a building on the map. By using this any library, I can do so using drag and drop feature. I will fill in the building attributes like building name as like I can write a number of attributes like its address, house, plot number. The important part is that I need to select the tenancy of the building, whether this building is a single tenant or multiple tenant. If I'm selecting multiple tenant, there are multiple home passes that are already present in the building. So I can select the category that whether the tenancy is for residential, for commercial, or for both. If I just click on residential, then I need to pass the home pass value, that how much home passes are there. Suppose I have entered that need to plan a solution for 10 home passes. So I have just entered the 10 home passes and I will save this detail. Once the detail will be saved, then a building will be appear here. As you can see, then if I want to see the attribute that I have created, I will click on the building, see its attribute, like whatsoever is the location or what is the attributes that I have filled, and I will approve the building. Now, at this place, you can see that as soon as that building is approved, the legend of that building got changed. It has now become a structure also at this particular location. Now, in this structure, if I want to see its information, that from here, from this window, I can configure its other attributes that will help in building design solution. What's the name? Suppose the structure name is tower 1. Its latitude, longitude are automatically fetched. Number of units, that's how many home passes are there as total 10. Number of occupants, how many persons are living in this particular building, and I can configure all these values. They are business passes also, then I can write it over here, and number of home passes that are 10. Similarly, for a specific building, if we are going to plan for the in-building solution, then there are shafts that are already located on the building. So I can configure the number of shaft value and its position with respect to the left shaft or right shaft. Also, there are multiple options that whether the shaft contain riser cable or not. So here I have selected that shaft must contain the riser cable so that they can allow that riser can pass through from them. In the next window for floor information, we will provide that how many floors are there in this building. I can configure the floor names. Suppose I want there is a basement in this and there are no home passes in the basement. I can write 0. Similarly, I can add n number of floors according to the home passes. Suppose at floor 1, I have the 4 home passes. At floor 2, I have the 6 home passes. Then I can update this value right here. As soon as I update this value, then these information are saved into this building structure. Now, I will place a FDC element to this structure so that will help in my in-building design. FDC is an element that will carry the network from primary splitter to the secondary splitter. So here with this, I can place a FDC by using this add FDC option. For the FDC, I can have the attributes like what is the FDC name. I will place it. Its latitude, longitudes are automatically fetched. Its item specifications are there. It's having total 72 ports. So the thing is that I need to plan that where will be the place where this FDC will be going to install. This is the structure ID. This is the base location. In this base location, I can select that this should be placed in shaft or a specific floor of that building. So if I have selected shaft, then it is asking me about which shaft. As I have configured 2 shafts, shaft 1 and shaft 2, so I have just selected a shaft 1. Then again it is asking me the floor. So as you can see in drop down menu that we have created basement, floor 1 and floor 2. So I can choose whatever I like. So according to the standard rule, I am selecting the basement and I'll save this value. Now FDC successfully. Now there is a FDC. Now to connect this FDC from the existing network, I connect FDC with the help of a cable. So I am just creating a cable from this nearest manhole to this FDC. I'll select the termination point, this, and create it. This is the any library by using which I can create any network element by using this any library using drag and drop feature. Now my FDC is connected with the existing network. Now move on to the ISP design. See, in this, if I open the ISP design of this, then you will able to see that this is the ISP in which a FDC will be there that is being placed in the basement of the building. Like in this ISP, I have configured these two shafts, shaft 1 and shaft 2. These are the floors like floor 2, floor 1, basement. And this is the entry point of the cable that is entering into this structure. This cable that is being created right now. On the left, you can see that these are the dimension of the floors that can be configured. Like these are the length, width, and height of the each floor. And we can in the units allowed that how many home passes, how many apartments are there in each floor. So this is the basement that will allow, don't allow any apartment. This is the floor 1. I have configured that 4 home passes should be there, and floor 2, 6 home passes should be there. If I want to see the information of this element that is already there, so this is an FDC. As you can see by its network ID, its complete details are already there. Total number of ports, n number of attributes that are bind to this FDC. Now, starting the in-building design, what I'll do is that with this FDC, I will place a fat box at floor 1. Like I will choose that where, what, in which shaft I need to place a fat box. In shaft 1, in floor, suppose I want to place a fat box in floor 1, then in this search element there is a fat box. So I will choose a fat box right here. You can see that fat box is placed successfully. Now with this fat box, I will place a splitter that in this cabinet, the splitter should be there. So I will select this fat box. I'll select this parent ID and splitter is there. So I can attach this splitter. I can also configure the splitter value according to my business requirement from this window. Now, with this fat box, the connectivity of home passes should be there, and the home passes are located on this floor 1. So I need to place the apartments over here. So what I'll do is that I'll select the floor, that is floor 1 is there. In the floor 1, I can place this unit. Unit is nothing but the apartment. I'll select the unit. Then you can see that a apartment has been formed, a structure has been formed. Similarly, I will select the 4 units, and after that it will not allow me to add any new unit after 4. Now, for each unit, as there are 4 units, so there should be the home termination box should be there with ONT and the customer details. So I want to add some information, some HTTP box at a particular unit. Like these are the 4 units that have been created right now. So I've selected unit 1. In this unit 1, I want to add a HTTP box. Again, HTTP box can be configured on the different configurations. Like we can configure an configuration of HTTP box. There are n number of specifications are there. So we can contribute. Similarly, in this unit 1, like this, and ONT will be placed here. and in this home there should be a customer that needs a connection. So I need to fill up the customer form number, like customer ID will be, this is the ID, customer name is, let's say Ajit is there. I can write the pin code value, its activation status, address, and its activation dates can be configured, type, and save these details. As soon as customer details are submitted, customer on the map on this floor design. Similarly, I can add these information into this again in the rest of the units. One STB box, one ONT, and one customer. I can select it, customer name, Ahmed. Similarly, its activation type, customer type, and save. So I have just added these customer details at this floor for this session. Now, the important point is that I need to configure the riser cable that will connect the FDC to this FAT box, and then FAT box will be connected to these apartments. So for the cable, what I'll do is I'll create a cable from this FDC to this FAT box by using this termination. As I drag the value from here, from this FDC to this, a cable has been drawn. I will save the information of this cable, like cable name is riser 1, its starting point, its termination point. So I can configure the dimension of the cable, like the length of the cable, like from 100 to 200 meters, the segment of the cable is this. Whether the category of the cable as distribution cable, this is there are different types of the cables, that whether it's a drop cable, riser cable. So I can configure this value, how this cable is being executed. So this is a riser cable, will be executed aerially, and save the details. I'll configure the cable again. Okay, like from this to this, a riser cable, starting point 100, 200, its distribution, riser, execution method, save. As cable saved successfully, as soon as the cable will be saved, then a cable will be shown like this, that this is a riser cable. Now again, I need to connect this FAT box from this HTB box. So I'll again connect a cable, like for this HTB box, I'll save it. Now this cable will be drop 1, length can be 200 to 200. So basically, this is start reading and end reading will tell that 20 meters of gas length has been consumed in drop cable activity. So these are the category of cable that is executed aerially, and save the details. So that you can see that these drop cables are, that drop cable is already formed here. Similarly, from this FAT box, one more cable will be connected to this terminal, and I can save the template. See, so this is how I can connect the different elements in building design, and using this. Now I need to connect these cables using splicing. So with this ISP model, we can splice the cable. Like for this FDC, I need to splice. So I will select a left cable, a right cable, and I can splice them. So by using this, I can splice the cables. On the top, you can see that this is the details of the splicing with the status as connected, reserved, faulty, and these how we can connect it. Similarly, I need to perform splicing at this FAT box. So I will select this FAT box, I'll select the left hand cable. I'll select the right hand cable for this fat box. This is the left hand cable, this is the right hand cable, and I'll splice it. In this fact there is splitter, so I will connect one cord with this splitter, and with this splitter I'll connect it to this HTB cable will be there. Similarly, this cable has been spliced at this location, and at HTB I need to again splice the cable. And I'll splice the cable to this box. Now there is a customer and ONT that are located over in this apartment. So by using this CP to customer, I will add the customer details to this HTB box. What I'll do is I will select the equipments like HTB box ID, ONT box ID, and you can see that I have fill a form of Mr. Ajit, that is a customer to this, splice these connectivities from ONT to this specific customer. Like this. Similarly, I will perform the splicing for this segment. What I'll do is I'll select this left hand cable, the right hand cable, and splice it. So as this is a splitter, the second core of the splitter, I will directly splice the cable, and again at this HTB box I do so. And at this HTB I can perform the splicing for the customers, like from this HTB to ONT and ONT to this customer. So this is how splicing works. Now, this is how I have created this network, and I can add n number of fat boxes according to their floor counts. I can add n number of floors to this. I can have n number of units, apartments that can be mapped as specific floors. So by using this, I can have these details. Now, you can see that this is the BOM that we can calculate, we can generate it into the CSV format of this ISP design. That these are the elements that have been part of this ISP connectivity. So I can have the BOM separately for this building. This building has FDC, fat box, the count is there, that there are one splitter, patch cord are 2, cables, unit, HTB, ONT. So this is the count that is being mapped into this ISP. I can generate this BOM report by a simple click, and this with BOM will be available in the CSV format. The Excel format, I get like this, having the length details of the cables, like how many cables are there, what is the calculated length of the cable. So this is how this BOM has been generated. Now this has been done. Now if I want to perform the splicing at this location to connect this new building with the existing network, I can do so. But suppose I want to splice at this particular manhole, because this is the new connectivity, so I need to connect with the existing network. I select the equipment over here, select the cable, select the 40 cable, and splice it. So this cable I will splice the 6th core here. Now this splicing works. Now if I want to see the information of these elements at this location, you can see that on the map I can see these are all the elements that have been placed. So in this ISP model, and if I want to trace a particular customer, like this is a customer, and whether its connectivity is intact or not, I can do so by using connection path finder, and I can trace its there is a customer, Mr. Amit. Has this customer been connected with my existing network? So I can choose the port and click on show route. See, this is the complete route of this particular customer from Amit, from the customer to the existing cable network. I can generate, I can see this detail on the map as well by using show on map. So you can see that this customer that is placed over here can be connected with my existing network. This is the trace of the network. I can see the schematic diagram, single line diagram of the network that is being passed up by different elements of the network like ONT. Then we have a patch cord connectivity with HTTP box. Then we have cable, fat box, splitter. So these connectivity can be generated on a fly and can be downloaded into the PDF and image format. So that's all for this ISP connectivity. And thank you.
Thank you, Harshit, for the wonderful demo of the solution. I hope it provided some info to our audience as to what the solution can provide to them. Now, I would request all my audience to, we'll begin with the Q&A session, and I would request you all to kindly type in your questions and queries in the Q&A window for our team to answer them. Also, I would request you to kindly fill up a small feedback form for us. I'm sharing the link on the same chat window for us to improve our webinars, upcoming webinars by looking at your feedback.
So while we're waiting for the Q&As coming in, let me take a couple of standard things that keep coming up all the time. So what I keep hearing most of the time from my customers is the in-building inventory part of the same inventory solution for the OSP and ISP? And all of them are managed in a single database of record? That's a standard question I keep hearing. The answer is absolutely yes. Whether it is the OSP elements, like the civil elements or cable elements, or the ISP, the OLT and ODFs and all those things inside a exchange building, or the in-building elements like risers and drops that Harshita just demonstrated. All of them are managed in one single database of record. And because all of them are managed in a single database of record, the whole end-to-end connectivity, irrespective of the domain that you're working on, is managed and maintained in a single system. The second question I get most of the time is, for the in-building solution that we just demonstrated, the flow plans and the flat layouts, are they static or are these dynamic? The answer to that question is it's dynamic, and how it actually makes up the whole drawing depends on the configuration information you provide. Like when Harshit initially tried to create an MDU, he mentioned how many floors that high-rise building is going to have, and how many flaps each of the floor is going to have. So based on that inputs the user input provides during the creation of the multiple dwelling unit, a system records that information and dynamically generates the layout of the multiple dwelling unit. Any questions coming up? Mansu, I'm not seeing anything
Yes,
on my
I don't. Yes. So I would still request my audience, if they have any queries, you can just type in, or we can move ahead and go ahead and close the session for the day. Also, if you have any queries after the session, you would like to have a demo for your one-to-one, you can share your queries on the email ID provided, that is marketing@leptonsoftware.com. I'm also typing that on the chat window. So I think there are no more questions that are coming up, so we can probably go ahead and close the session for the day. So I would like to thank Mr. Shyam and Harshit for the wonderful presentation and demo for the about the software and the solution. I hope the session was useful for all our audience, and looking forward for your attendance on our next webinar. We will share the details with you on your email. Thank you and have a great day ahead. Stay safe. Goodbye.